Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. The topic is still effect of an electric current on substances. If you remember in the previous lesson, we were discussing electrolysis, and we said that the electrolysis is a process of passing an electric current through a substance and it gets decomposed by the electric current. And then we did examples of substances or molten substances which when you pass electric current, they will be decomposed. These ones included copper chloride or copper 2 chloride, lead 2 bromide, lead 2 iodide. Those are some of the examples of molten compounds we did in electrolysis. And we say that when you pass electric current through that electrolyte, then this electrolyte gets decomposed by that electric current. And therefore you have ions. And these ions, they now start migrating in now different electrodes, that's the cathode and the anode, where we said that the positively charged ions migrate towards the negatively charged electrode, while the negatively charged ions migrate towards the positively charged electrode. That is electrolysis, and again we wrote equations on what happens when various ions are deposited at the anode and the cathode. For example, when it was electrolysis of molten lead 2 bromide, this solid, we say that first of all you need to heat it, because in solid state it does not allow the passage of electric current, because the ions in lead 2 bromide are held together in fixed positions. The electrostatic forces of attraction are holding the ions of lead 2 bromide together very strongly, and therefore the ions are in fixed positions, they do not move. So heating weakens the electrostatic forces of attraction and the ions become mobile. Therefore, when this one is heated, then you have lead ions and bromide ions. They are now in liquid state. This is after heating. So that heat has weakened the electrostatic forces of attraction. And therefore, that's why the ions are now free. They are now mobile. They can be able to move. And therefore, these positively charged ions, we said they will now move to the cathode, and these negatively charged ions will move at the anode. And therefore, the equations at the anode, we said it will be bromide ions will lose electrons, and bromine gas is going to be produced at the anode. And at the cathode, lead ions they are gaining electrons, and lead metal is deposited at the cathode. Those are the equations of what happens at the anode and the cathode. I hope you got that very clearly, and ensure that you practice more on that so that you are able to write the equations at both the anode and the cathode correctly. Ensure again they have the physical states and they are also balanced. In this lesson, I want us now to discuss on applications of electrolysis. Where are some of the places where electrolysis can be applied? And one of those areas So this electrolysis is applied in so many processes, and one of the processes is in extraction of metals. Extraction of metals such as sodium, magnesium, aluminium. So extraction of these metals requires the electrolysis method for them to be extracted. For example, sodium, you extract sodium from sodium chloride because sodium is a very reactive element and it does not exist as a free element. Magnesium also does not exist as a free element, same to aluminium. They are found in form of compounds. Therefore, these compounds need to carry out electrolysis so that you can be able to remove the sodium from their compounds, magnesium from their compounds, and aluminium from their compounds. And this process is electrolysis. For example, sodium, you get sodium from sodium chloride. Then for you now to be able to extract this sodium from sodium chloride, you need electrolysis process. You need to conduct electrolysis so that this sodium will be deposited at the cathode, while the chlorine or the chloride ions will be deposited at the anode in form of chlorine gas. That is how you are able to isolate, or you are able to separate sodium and chlorine from sodium chloride. The same thing happens in magnesium. You get magnesium from magnesium 2 chloride, and aluminium from aluminium 3 oxide, or the compound which is called the bauxite, which again you're going to learn about this electrolysis later in the coming topics in future. Therefore, one of the applications of electrolysis is in extraction of metals such as sodium, magnesium, and aluminium. Electrolysis knowledge is required in extraction of those metals. The second, and you're extracting these metals from their molten compounds. Extraction of metals such as sodium, magnesium, aluminium from molten compounds. From molten compounds. The second application is in purification of metals. Electrolysis can also be used in purification of metals. An example, if you want to purify copper, they need to ensure that the electrolyte has copper ions. That is one, the electrolyte must contain the copper ions. Second, the pure copper should be made the cathode. The pure copper is made the cathode. So there is pure copper, which is now made the cathode, and the impure copper is made the anode. And therefore, what happens? The copper ions from this solution will gain or will be attracted to the negatively charged electrode, which is the cathode, and they will gain electrons at the cathode, and copper will be deposited. And therefore, what happens at the anode, not at the anode but the cathode, the copper ions are now migrating because they are positively charged. They get attracted at the cathode, and they migrate towards that cathode. Then at that cathode, these copper ions gain electrons and they are deposited. Deposit copper metal. And therefore, the copper metal here, or the size of this copper, this copper cathode will increase. The copper cathode will be increasing in size. That is what happens at the cathode. The copper ions gain electrons and copper metal is deposited at the cathode. Therefore, the solution must contain copper ions, and the copper and the pure copper should be made the cathode. And that is how electrolysis, this is the electrolysis process, and that is how electrolysis can be used in purifying metals. What happens at this anode? The copper metal will be losing electrons. You'll have copper ions. Electrons are lost. This is the equation at the anode. So at the anode, the copper loses electrons, and copper ions are deposited, or they join the solution. The copper ions join the solution, and the copper ions in the solution, they get attracted towards the cathode, and when they get attracted towards the cathode, then they gain electrons and they are deposited as the copper metal, and therefore the impurities will be left out, and the pure metal, or this impure copper, will have been purified. That is, electrolysis process again can be used in purification of metals, and you're going to learn again more on this in the upcoming topics. That is the second application. In the third application, it is also used in electroplating of metals such as iron to improve the appearance and prevent corrosion. Electroplating metals such as iron to improve their appearance and prevent corrosion. Electroplating just simply means coating a metal with another metal, or it's electrical, or it's a process of coating a metal with another metal through electrolysis. And if you want to coat a metal with another metal, this is what happens. If you want to coat iron metal with a metal like copper, then iron metal should be made the cathode, like we've done here. This is the cathode because it's connected to the negative terminal of the power source. This is the cathode. So the metal to be coated should be made the cathode. Then the metal which you are coating, that substance which has been made the cathode, then should be made the anode. And the solution again should contain the ions of the metal you want to coat iron with. Therefore, if you want to coat this iron, then with copper, you want to coat this iron metal with copper, then the solution should contain copper ions, and that's why you have copper 2 sulfate solution, and the anode is made of copper metal. And by that, then you will, because what will be happening, the copper ions at the cathode, the copper ions in the solution will gain electrons and they're deposited as copper metal. Therefore, these copper ions inside will gain electrons and they will be deposited on the surface of iron. And that is how you coat a metal with another metal. I hope you understand that. Copper ions in this solution gains electrons. Once they gain electron, they are deposited on the surface of the cathode which is now made up of iron metal. That is electroplating. And electroplating is done because of two reasons. One, you want to improve the appearance. You want to make a substance more appealing. To improve the appearance, it may look good so that it may look attractive. That is one of the reasons why you conduct electroplating. And second is to prevent corrosion. Corrosion, this iron, iron is prone to reaction with atmospheric oxygen and moisture, and it will rust. Then when it rusts, now it looks burnt, or it may not stay for a longer time. And that's why, again, you need to coat it with a metal which does not corrode easily when it comes into contact with water and atmospheric oxygen. Therefore, those are the two reasons why you conduct electroplating: to improve the appearance, or making substances more appealing or more attractive, and preventing corrosion. The last application of electrolysis is manufacture of pure chemicals such as hydrogen gas, chlorine gas, and sodium hydroxide. Manufacture of pure chemicals such as hydrogen gas, chlorine gas, and sodium hydroxide. Manufacture of these chemicals, again, requires electrolysis process. Therefore, if you want to get pure chlorine, like we were saying, if you want to obtain pure chlorine from sodium chloride, then electrolysis again needs to be conducted so that you get chlorine alone from the sodium chloride. Therefore, manufacture of these chemicals, or these pure chemicals, also applies the knowledge of electrolysis. Therefore, you are able to obtain pure chlorine, pure hydrogen, and also pure sodium hydroxide. So we are going to discuss about how, or electrolysis, how you are able to manufacture sodium hydroxide using electrolysis process. Again, that is now later in the syllabus. Therefore, those are the applications, or some of the applications of electrolysis. Therefore, some of the applications include extraction of metals such as sodium, magnesium, and aluminium from molten compounds. They are not the only metals, but these are some of the metals. Then how you are able to obtain them from the molten compounds. From this compound, you are able to obtain sodium. From this compound, you are able to obtain magnesium. And from this compound, you are able to obtain aluminium metals. Then they applies the knowledge of electrolysis, because these are very reactive metals. They do not exist as free elements. They are found combined with other substances. Then second, it is also applied in purification of metals, and I've explained to you how it can be used to purify a metal. When you want to purify a metal, then the pure metal should be made the cathode, then the impure metal should be made the anode, and the solution or the electrolyte should contain ions of the metal which is being purified. I hope you get that. The next, it can also be applied in electroplating metals such as iron. You can use it to electroplate metals such as iron. And there are two reasons why you conduct electroplating. One is to improve the appearance of a substance or a metal or maybe some utensils or something, some ornaments and something like that. You want to improve the appearance, you want to make them more appealing, you want to make them more attractive. And second, you want to prevent corrosion. There are those substances like iron which corrode very fast when exposed to water and oxygen. They just corrode. And therefore, if you coat with another metal which does not react easily with water and oxygen, then again, you'll have prevented corrosion of this metal. And that is how you conduct electroplating. I've explained to you that the metal to be electroplated should be made the cathode. Then the metal which is coating that metal, which is coating the metal, is now made the anode. And the solution again should be, or should contain ions of the metal. You are coating iron using, and in our case here, it was copper. And lastly, electrolysis can also be applied in manufacture of pure chemicals such as hydrogen gas, chlorine gas, and sodium hydroxide. These are just some of the pure chemicals which, again, the manufacturer applies the knowledge of electrolysis. Therefore, that brings us to the end of our lesson today, but I will leave you with this assignment. And the assignment is state 4 applications of electrolysis. Should be able to state 4 applications because we have learned that, and you should be able to do that. That brings us to the end of this lesson and this chapter. If you go back to the objectives we stated at the beginning of this lesson, then ensure that you have been able to achieve all those objectives. If you have not achieved, then you need to go back to your work or to go back to the previous lessons and learn. Ensure that you understand each and everything we stated in the objectives. Ensure that you've achieved all those objectives. It's about defining the terms. It's about stating the applications. It's about writing equations at the cathode, at the anode. Ensure that you have done that.